Let's go ahead and go through this bell work. So what do they want me to find here? Want me to find the volume. And it did that zoom in thing again. There we go. So how do you find volume? Length times width times height. So what is the length of this box? So my length across the bottom, although it doesn't technically matter which one you call length, width, and height, because you're just going to multiply them all together. But I called this one my length. So I take 8x minus 3 times my width. What's the width of the box? 3x plus 4 is what I called my width as well. And then what's the height of this box then? The height is x. This piece right here is our height. So we're going to multiply that by x. How many things can we multiply together at a time? Just 2. I usually go with the 2 most complicated ones first, because I like to get the complicated stuff out of the way, and then I deal with the easier part. So let's multiply these 2 pieces together. I'm going to drop this part down, and we're going to look at just these 2. 8x minus 3 and 3x plus 4. How do I multiply those 2 together? Yep. 8x gets distributed to 3x. What's 8x times 3x? 24x squared. Then I have to distribute 8x to 4. What will that be? 8x times 4. 32. Just 32? 32x. Am I done distributing? We got to do the 3 also. So I'm going to take the negative 3 and distribute that here. What is negative 3 times 3x? Negative 9x or minus 9x. Anything else I need to do? Negative 3 times 4, which gives me what? Negative 12. Don't forget to do those pieces in the middle. We have to take everything in the first set of parentheses and multiply it to everything in the second set. All right, so that's from my first bit of multiplication. Don't forget to bring this guy down, because we still have to multiply him. Are there any like terms for me to combine together here? The things I just underlined, you're absolutely correct. What do I get when I combine those 2 pieces together? 23x. So 24x squared plus 23x minus 12. And I need to take that and distribute it to x. So I take this 24x squared. I distribute that to the x. What does that give me? 24x to the third. What else do I need to distribute to the x? 23x. So that becomes 23x squared. Anything else? So minus 12x. That is my volume. I do not have any more like terms to combine together. All right. Do you guys have any questions about this one? All right. In that case, go ahead and pull out your test review packets. Yep, I'm not taking anything away yet. We're going to start with number 8. We did number 9 yesterday because we had some time, but number 8, I said, took more time. So we'll do 8. If anybody wants a refresher on number 9, we'll do a refresher on that one also. And then we'll do the problems on the back page, and that will finish up pretty much the entire packet. I think that leaves like one problem for you guys to do totally on your own. Answers are going to be posted, so you can check your work against mine also there. All right. All right. So I want to do number 8, part A, and then I'm going to give you guys a couple minutes to do part B on your own, and then we'll check your work against mine. All right. On number 8, part A, I see outside of the parentheses 2 different operations being mentioned here. Again, outside of the parentheses, so I'm not looking at the plus, I'm not looking at the minus. What are the 2 operations that I'm seeing outside of the parentheses? Squared and multiplication. Multiplication right here, squared right here. Which one do I do first? Squared first. Exponents always come before multiplication. What does it mean to square something? Multiply it by itself. So 3r plus 4 is going to get multiplied to another 3r plus 4. Talk to me about the distribution that we need to do here. 3r needs to get distributed to what? 3r and the 4. What is 3r times 3r? 9r squared. What is 3r times 4? 12r. All right. Am I done with my distribution? No. What do I still need to distribute? The 4 in my first set of parentheses needs to get distributed to both pieces. So 4 times 3r plus 12r. 4 times 4? 16. Yes. What do you mean? You got it? Okay. When we square a binomial, it's not the same thing as just squaring the first piece and the last piece. Because if all you did was square the 3r and square the 4, you would get this part and you would get this part, but what would you be missing? The 2 12r's in the middle. So you have to do your double distribution if you're squaring a binomial. Are there any like terms for me to combine together? 12r and 12r. So do those cancel and give me a 0? No. What do I get when I combine those? 24r. So 9r squared plus 24r plus 16. Is that my final answer? No. What do I still need to multiply that to? 2r minus 5. This guy right here needs to get brought down. How many things am I going to have to end up distributing here then? 3 things to 2 things in my second set of parentheses. That's a lot of distribution. One of the things that you can use, and I didn't show this before, but I want to put this tool in your pocket for tomorrow in case you choose to use it. Sometimes it's easier to see what's going on if I arrange this in something called an array. I'm going to use an area model or a box to help me arrange this. So if I want to use an array to help me multiply, excuse me, I'm going to draw a rectangle. Do you see how the polynomial in purple has 3 terms? I'm going to take one side of my rectangle and I'm going to break it into 3 parts. And I'm going to write one term above each part. Excuse me. So I have 9r squared, 24r, and 16. And my other polynomial has how many parts? 2. So I'm going to take the other side of the rectangle and break it into 2 pieces. And I'll put one term with each part. This is a way that I can make sure that I don't miss any of the distribution that I would need to do. And it helps me arrange it in a way so that I don't lose any of those pieces. I'm going to multiply the rows and the columns together now. So I'm going to take 2r. I'm going to multiply it to 9r squared. What would that give me? 18r cubed. And then I'm going to take this top row, 2r, and I'm going to multiply it to the next column. So 2r times 24r. 48r squared. And then I'm going to do the top row with my last column. 2r gets distributed to the 16. 32r. All right. So this is like taking my 9r squared and distributing it here, taking 24r, distributing it here, take 16 and distribute it. I still need to take my -5 and multiply it, excuse me, by each column. So what is -5 times 9r squared? -45r squared. Give me just a second to grab a drink of water here. Oh, that's much better. Then -5 times 24r. -120r. You were ready for that one. And -5 times 16. -80. Have we done all of the distribution? Yes. And this is one of the reasons why the more terms we have, this can be really helpful because I see all of the places where I would need to fill in and I make sure I haven't missed anything. There's something else really helpful about doing it with an array like this. Where are the like terms that I need to combine together? My r squareds, they're right here along this diagonal. Are there any other like terms that I'm going to need to combine? My r's, which are also arranged on this diagonal. So I can look at those diagonal pieces. They're not one on top of the other, which would be super helpful, but they're very close and touching on the corners so that I can see that. All right, let's write down our final answer then. Did 18r cubed have a like term? Nope. So I have 18r cubed. I need to combine -45r squared and 48r squared. What do I get when I combine those two? 3r squared. So it's plus 3r squared. -120r and 32r. -88r. And then did we have a like term for -80? Nope. So -80. That would be my final answer for part A. Take about 5 minutes, between 3 and 5 minutes. I'll kind of judge as I walk around the room when everybody's done. But between 3 and 5 minutes, I want you to do part B on your own. That's going to be just like this part right here. You don't have a third binomial to multiply with. So it should be quite a bit shorter than part A. Answer. Yes, sir. Yes, absolutely correct. Do you have any like terms to combine? There you go. That looks great so far, Emily. Work on part B for me. Nope. Those pieces are all correct. Hold on. Hold on. Let me see.
Well, you said this isn't right.
Hold on. Let me look at this. No, you are right. Yes. Sorry. My brain was combining things wrong.
Is this right?
Yes, so far you're absolutely correct. Jane, look at that one more time. Check your middle one. Check that part right there. Beautiful. Beautiful. You have to do the double distribution.
So I did the double distribution. That's when you are 4R plus it's just -1.
How did you get -1?
Because -3 plus 1 times -3 times 1
is not 1.
I mean -3. That's my bad. So after that,
so you have to take this and multiply it to both parts, and then you have to take this and multiply it to both parts.
So after, how do I get to the third step?
Combine your like terms. And then you're finished. So once you're working on this part right here, dear. Part B.
Oh.
You're supposed to work on part B right now. You're done.
Oh, I'm done?
You're done.
Oh.
All right. As I'm walking around the room, it looks like most people are either done or stuck. So let's go through this together. How many pieces does the first binomial have? 2. How many parts does the second binomial have? 2. How many total distributions are we going to need? 4. Both pieces of the first binomial have to get distributed to both pieces of the second binomial. So tell me what the first thing is that I'm going to multiply together. 4R times 5R, which gives me what? 20R squared. What's the second thing I'm multiplying? 4R times 1. Remember, the first part of my first binomial has to get distributed to everything in the second binomial before I can move on. So I have plus 4R. What distribution do I still need to do? That -3. What do I need to distribute that to? Has to get distributed to the 5R and to the 1. What is -3 times 5R? Close. -15, just -15? -15R. And then when I distribute the -3 to the 1, what do I get? -3. Are there any like terms to combine together? 4R and -15R. What do I get when I combine those? -11. So I have 20R squared minus 11R minus 3. Do I need to multiply that to anything else? No, I only had 2 things up here to multiply together. I multiplied them, combined my like terms, and I'm done. Why did we have more steps over here on the first one? because it had the squared, so I had to end up multiplying 3 pieces together. Because I had to square it first, and then I had to take that answer and multiply it. Thank you, sir. All right, is there anybody that feels like they need to see number 9 again? All right. Let's hit on the most important pieces real quick. What do you notice about the second binomial, the one that comes after the division? There's only one piece. What do we call a polynomial that only has one term? A monomial. When you have a monomial, synthetic division is not allowed. When you have a monomial, long division also isn't going to work. So how do I do this if I can't use long division or synthetic division? Yes. I would rewrite this 81 x to the 8th plus 36 x to the 5th minus 27 x squared over my monomial 3x squared. And then I'm going to take that monomial and I'm going to distribute it to each of these terms. I only do this with monomials. If you see a plus or a minus in the thing that you are supposed to be dividing it by, you don't use this way of doing it. Only when you have a monomial. All right, so I'm going to write down what it looks like after I distribute it. So 81 x to the 8th over 3x squared plus 36 x to the 5th over 3x squared minus 27x squared over 3x squared. Then we divide our numbers first. What's 81 divided by 3? 27. So I look at the number part of the fraction first, and then I go look at the variable part. X to the 8th divided by x squared would give me what? X to the 6th. Because remember, x to the 8th, if I wrote that out, I would have 8 x's all multiplied by each other up on the top. On the bottom, I would have 2 x's multiplied together. So those 2 are going to cancel with 2 from the top, and I would have 6 left over. That's why it's x to the 6th. Then I move on to my next fraction. Same exact thing. 36 divided by 3 would give me 12. And then I go look at the x part. X to the 5th divided by x squared will be x to the 3rd power, yes. Bring down my subtraction, and I come over here to the last fraction. 27 divided by 3, 9. And what happens with the x's? They cancel completely out. I have 2 that are getting multiplied together on the top and 2 on the bottom. Yep. So both pieces cancel, so it's just that 9. That would be my final answer there. All right, go ahead and flip it over to the back side. 3 problems to go, and then we are done. What do you notice about this problem? Looks almost identical to the bell work. We're going to approach it the exact same way. Volume is equal to length times width times height. What's my length? 2x plus 5. What's my width? 2x minus 5. And my height, 3x. And Shadrach, it technically does not matter what order you write these down in. So if you said my length is 3x, that would be fine. As long as you have all three pieces that are being multiplied together, it's totally fine. I'm going to multiply the more difficult ones together, the harder ones, the ones with pluses and minuses. So I take 2x plus 5, and I have to distribute that to 2x minus 5. Thank you. Tell me all the things I need to distribute. 2x goes to 2x. Let me get a different color up real quick. So 2x times 2x is what? 4x squared. What else do I need to multiply? 2x and negative 5. What does that give me? Negative 10x. All right, what else should I multiply? 5 and 2x, which gives me 10x. That's a positive 10x. Anything else to multiply? 5 and negative 5. What do I get when I multiply those two together? Negative 25. Are there any like terms that I need to combine together? 10x and negative 10x. What happens when I combine those? They cancel out. So does that make this my final answer then? We still have that 3x that we need to bring down. All right, I'm going to have to swing my work up and around over here. All right, so I have v equals 4x squared minus 25 times 3x. What do I need to distribute? 3x and what? 3x and negative 25, which would give me what? Negative 75x. Do I need to distribute anything else? 4x squared also needs to be distributed. 12x to the third. That would be my final answer. Remember, when we're multiplying polynomials, every part of the first polynomial has to get distributed to every part of the second polynomial. Any questions about this at all? All right. 2 to go. Let's go look at number 11. What method do they want me to use on number 11? They want me to use synthetic division. First thing they ask is, we're going to put what number in the box? This piece right here. Close. Negative 7. Why is it negative 7 and not positive 7? How do we get it? Take this right here and set it equal to 0. X plus 7 equals 0. To get the x all by itself, I have to subtract 7 from both sides. So x is negative 7. All right, so I put that here. What do I put after it? Yep, I heard 5. Where did the 5 come from? 5x to the 4th power. So we start with x to the 4th power, and I need that coefficient. Then what number? Negative 10. That's the coefficient on x cubed. Then what? Positive 3. That's the coefficient on x squared. Negative 4. That's the coefficient on x. And 6. That's my constant. After I have those written down, I do my equal sign with the little leg. A lot of times I like to put a little dash in here so that I make sure I know it's just this piece that's off by itself. What will this be back here? That will be the remainder. All right, tell me where to start now. Bring down the 5. So I have a 5 right here. Then what? -7 times 5. So I'm going to multiply this. What is -7 times 5? -35. And I add these pieces together. What is -10 plus -35? -45. What do I do after that? -7 times -45. That's kind of big, isn't it? 315. And I add that to the number up above, which gives me what? Gives me 318. Right? What next? -7 times 318. What do we get? -2,226. I add it to the number up above, which gives me negative what? 2,230. Can I be done yet? Nope. One more. -7 times -2,230. I know it's going to be a positive, right? 15,610. I add it to the number up above. I get 15,616. This remainder goes over my denominator. All right, let's write down our final answer now. This is 5 what? X cubed? Yes. Why is it x cubed and not x to the 4th? Yes, we go down 1 degree. This was x to the 4th. And so this one down here will be x cubed. So I have 5x cubed. And then what? Yep, minus 45x squared. This had been my x cubed, so it drops a degree. Minus 45x squared. Then what? Plus 318x. Then what? Minus 2230. And now we get to that remainder. Is the remainder positive or negative? Positive, so I put a plus. I'm going to need a fraction. What goes up on top of the fraction? Yep. 15,616. Down on the bottom, what were we dividing by up at the original problem? X plus 7. This came from here. That would be my final answer there. All right, we've got one last problem to look at. Something I want to mention before we go on to the next problem. This is not one that you could factor because we had a remainder. Whenever you have a remainder, that's as far as you can go. You have to stop right there. There is no further that you can go with a remainder. If you get a remainder of 0, then you can keep going. Then you can keep factoring. Let's look at our last problem. So using either long or synthetic division, we want to find 2x cubed minus 3x squared minus 14x plus 15 divided by x minus 3. Do you guys want to use long division or synthetic division? Synthetic sounds good. So what goes in the box? 3. I take x minus 3. I set it equal to 0. So I would add 3 to both sides. X equals 3. That's what goes in the box. So what do I write down after it? 2. And then negative 3. Negative 14. And positive 15. Equal sign with a little leg. I always like to dash them off. What do I do now? Bring the 2 down. So I have a 2 here. And then what? 3 times 2. So we're going to multiply this. Write my answer down here. What is 3 times 2? 6. I add that to the value up above. Negative 3 plus 6. Positive 3. Negative 3, so I'm standing at negative 3 on the number line, and then I add 6, so I go to the right 6 hops. Then I take 3 and I multiply it to 3, and that gives me 9. I add that to the value up above. Negative 5. One more time, 3 times negative 5. Negative 15. Add it to the value up above, and I get 0 as my remainder. Okay, so help me. This 2, 3, and negative 5, what does that look like when I write it all out? 2x squared negative 3x positive 3x. And then what? Minus 5. This one had been an x cubed, so it dropped a degree, and this became an x squared. This one had been an x squared, dropped a degree, so this became x. This one had been just x, so this is now my constant. And this one had been my constant, and I had a remainder of 0. Can I, for extra credit, do more with this? Yes. If I stop right here on the test, will I get penalized? Nope, you'll get full points right there. But let's look for the extra credit part. I don't throw around extra credit very often. You will get extra credit if you take this one more step. X squared plus 3x minus 5. How can I find the other roots? I have one of them already. Yep, we're going to do our box. This is my area model, my array, and my x. What goes here? Two what? 2x squared. What goes down here? Negative 5, my c value. How do I find out what goes in these two spots? That's what the x is for. So I take the coefficients on a and c, and I multiply them together. What are the numbers I'm multiplying here? 2 and negative 5. What do I get when I multiply those? Negative 10. What goes on the bottom? 3, my b term. What numbers do you know of that when I multiply them together, I get -10, but when I add them together, I get a +3? 5 and -2. So I come over here and I put those here. And I forgot something. I need X's on those because remember, together, those are giving me this. When I put things in that area model in that box, it's just another way of representing my original trinomial. All right, what do 2x squared and 5x have in common? They have an X in common. What do -2x and -5 have in common? -1. What about 2x squared and -2x? 2x. 5x and -5? 5. Positive or -5? Positive. Okay, I found them. Do I get all the extra credit that's on the table if I stop here? No. How do I get the rest of the extra credit that I want? Set them equal to 0. So x minus 1 equals 0. 2x plus 5 equals 0. Let's do this one first. What do I do to solve that one for x? Add 1 to both sides. So x equals 1. What do I do here to solve this one for x? Subtract 5 from both sides. So 2x equals -5. And then what? Divide both sides by 2. Those are being multiplied. So I get rid of it with division. So x equals -5 over 2. So tell me what my roots are. X equals 1. I heard x equals 3. And x equals -5 over 2. Absolutely. Where did that 3 come from again? Yep, from this right up here. That was one of my roots. All right. Doing that second part over there will get you extra credit. Quite a bit when you compare it to what the entire test is worth. I think the test says it's worth 2 points, but when you think of that in terms of percent, it comes out to be quite a bit percent-wise when you look at what the whole test is worth. I think if it's not a whole letter grade, it's close to, like, it would be at least half a letter grade there with those 2 points of extra credit. Just looking at how many points there are on the whole test. So it's definitely worth it. It's the difference between like a 79 and an 84 on there. Do you guys have any other questions for me about anything at all on the review? Cool beans. Let me know if you guys do have any questions or if you want additional practice problems at all. What do you have to do tomorrow when you come in before I will hand you a test? Phones. There will be a basket on my desk. There will be a basket on that rolling cart over there. There will be Post-it notes if you want to put your name on your phone, and I will monitor as people are picking them up to make sure that nobody takes a phone that does not belong to them. Yes, sir. You'll turn bell work you'll turn in today if you want, or you can turn that in tomorrow if you want it to study with. And then the review you'll turn into me tomorrow. Did you have a question, Chloe? Chloe, did you have a question? Yes, you may.